Okay, now let's look at question number 12, part A, combinations and permutations question. So you have three sets given, these three, and we are required to form a 5-character password using the elements in these three sets. So the first one, find the number of different elements. So no repetitions, okay? No repeating elements. Can be formed using above different elements. So what's the first one? No restrictions are placed on selection. So you want to create 5-character password. No restrictions are placed. So first position can be filled in 9 ways, second in 8, third in 7, fourth in 6, and fifth in 5 ways. So multiply them all together. 72, 30 into 7, 210. So 72 into 210 is 15,120. Right. So this can also be found using combinations. So you have to pick what? 5 terms out of 9. So that is 9C5. And the order matters. So you have to multiply by 5 factorial then. Then you will get the same answer like this. This is the number of ways to pick 5 terms out of 9. Then you have to think about the order. Here it's order matters. Okay. So you can get the same answer using that also. Right. So then part 2, exactly 2 digits. So then we have to pick 2 out of this. So 3C2. Then the rest of the 3 terms comes from this one, 6C3. Then again you have 5 different elements, so you have to find the arrangements. Order matters, so you have to multiply by 5 factorial. So then let's look at the answer. 3 into 6C3 is what? 20. 20 into 5 factorial, 120. 60 into 120 or 7,200 passwords are possible. Right, then let's look at second part. Find the number of different passwords that can be formed using above elements such that exactly one element from P1, exactly 2 elements from P2, with repetitions allowed only for elements in P3. Right. So P1, P2, P3. One element from P1, 2 from P2, and 2 from P3. Repetitions are allowed for P3 also. So let's look at this one. So this is case 1. 1 from P1, 2 from P2, 2 from P3. Let's say distinct, non-repeating case. Let's consider the non-repeating case. Then how many arrangements are possible? P1, you want to pick 1 out of 3, so 3C1. Then from P2, 2, so 3C2 times. You have to pick 2 from P3, so again 3C2 and 5 different elements, no? So 5 factorial. So find that 3, 3, 3. So 3 times 3 times 3 times 5 factorial is 120. So 27 into 120. So that is what? 2700 and 540, right? 2700 and 120. 270, 270, yes, through 3240. Right, now let's look at case 2. Second case is P1 one element, P2 two elements, all are different for those. P3 two are there but repeated. So then you can pick 1 from 3C1, 2 from 2, 3C2, again 2. Now, how many ways to pick from P3? There are 3 options, no? 3C1. Then the number of arrangements, 5 factorial over, this is repeating, no? So you have to divide by 2 factorial. So this is going to be 3 into 3 into 3 into 120 over 2. So that is half of what we found earlier. So 1610. 1610. So add them together, you get the number of passwords. 3240 plus 1610. 4830.